In the last video, we discussed the basic functional units of the processor, how they are interconnected, and the data path for the instruction at location A, R0. Now consider the instruction at R0, location A, where we would like to add the content of the memory location A with the content of the general purpose register R0 and keep the result in the memory location A. First of all, we need to fetch the instruction. The address of the instruction will be available in the program counter. From there, it has to be kept on the external address bus through memory address register. Hence, the content of the program counter, which is the address of this instruction, will be transferred to the memory address register and from there to external address bus. At the same time, a read control signal is issued by the control unit to the external control bus. So the data corresponding to the address on the address bus, which is this instruction, will be read from the memory to the external data bus, and from there it will be read to the memory data register. Because the external data bus communicates with the processing unit through memory data register. From the memory data register, the instruction will be transferred to the instruction register and will be ready to be decoded. Thus, the instruction within the instruction register will be decoded by the instruction decoder and control unit to identify the further operations to be executed. Decoding the instruction will identify that some operands have to be fetched, one from the memory, other is already available in the general purpose register. Then an ALU operation is required. Also, the result has to be written back to memory. So the instruction is ready to be executed. First of all, the operands have to be fetched, one from the memory. In order to fetch and the other from the register, in order to fetch from the memory, the address corresponding to that operand will be made available in the memory address register, and from there it will be kept on the external address bus. At the same time, a read control signal will be issued by the control unit to the external control bus. So the data corresponding to the address on the address bus, which is the operand at memory location A, will be read from the memory to the external data bus, from there to the memory data register. So we have fetched one operand to the memory data register within the processor. The other operand is already available in the general purpose register R0. Both the operands will be fed to the arithmetic and logic unit. Proper control signal for add operation will be issued. Now the result is available in the temporary Z register. The result should be written back to memory location A. So one memory write is required. For that, the address to which the result has to be written will be made available in the memory address register, and the result which has to be written will be made available to the memory data register. It will be transferred from the Z register to the memory data register. From the memory address register, the address will be kept on the address bus. From memory data register, the result will be kept on the data bus. At the same time, a write control signal is issued. So the result will be written to the address available on the address bus. And by the time one instruction is fetched and kept in the instruction register, the content of the program counter can be incremented to point to the address of the next instruction to be executed. So here, while transferring the content of the program counter to memory address register, the address within the program counter will be available on the internal processor bus, which can be directly fed to the ALU as one operand. Instead of register Y, 4 can be selected as the other operand. Proper control signal for add operation can be issued. The result will be available in the Z register, and from there it can be again transferred to the program counter. So by the time this instruction execution is over, the address of the content of the program counter will be updated. So there should be a data path to the program counter also in order to update the program counter. So normally we can say every instruction consists of three phases: fetch phase, decode phase, and execute phase. And each phase may involve a set of operations such as memory read, ALU operation, memory write, or simply register to register transfer. And at the very lowermost level, if we consider every operation, this is a register level data transfer. So we can consider each instruction to be consisting of one or more of the following operations: data transfer between registers, or data transfer from register to memory location, or from memory location to register, then between registers and ALU, or some ALU operation. Every instruction will be consisting of one or more of the following operation, but in a proper sequence in a controlled and timely manner. In our case, the address of the instruction should first move from the program counter to the memory address register, then from the memory address register to the external bus, and at the same time a read control signal should be kept on the control bus. And when the data is available on the data bus, it should be transferred to the memory data register. Following it, from the memory data register, the instruction should be transferred to the instruction register, and so on. So how these proper data movements are made possible in a controlled and timely manner with the help of the control signals. The control signals are produced in the proper sequence and at proper time in order to regulate the data movement required for the operations corresponding to each instruction. So next, let's see how the control signals properly control the data movements required for the operations corresponding to the instruction add R0, location A.